We're going to deal with acceleration now. An acceleration is when we change the velocity. Okay? So it's important to keep your common sense and your own knowledge of life intact here. Sometimes in physics it's easy to think, oh, I don't know that. But actually you do. Because if I told you that a car went from 0 meters per second, which is a velocity, to 10 meters per second, and I asked you what the car had been doing, you would actually be able to say that it's accelerated from 0 to 10 meters per second. Okay, its velocity has changed. And if we were to look at this on a velocity time graph, it would have gone from 0, 10, 20, 30. It's gone from 0 to 10. Now the question is, how long did that take? And this is what acceleration is. It's the rate of change of velocity. And so if we look at this here, can you see that if this was here 2 seconds, then this car will have gone from 0 to 10 meters per second in 2 seconds. So the change in velocity we can calculate by and this is the formula you need to know, the final velocity minus the original velocity over the time taken. And so, if we fill in the gaps here, we've got, in this car, we've got a final velocity of 10 meters per second. It started off at 0 meters per second. And it took 2 seconds, according to this graph. So, 10 minus 0 is 10, divided by 2, equals 5 meters per second increase in velocity every second. So it's 5 meters per second, and we actually write that as 5 ms to the minus 2. Velocity is ms to the minus 1, acceleration is ms to the minus 2. So we can compare velocities. So for example, let me give another velocity here on this graph, for example. We go from 0 to 30 in 2 seconds. Let's use our formula. We finish off at, so the acceleration equals 30 meters per second, which we finished off at. Started off as 0 meters per second, and it took 2 seconds. So 30 minus 0 is 30, and it took 2 seconds. And so there we've got an acceleration of 15 meters per second. So each second the car increased its velocity by 15 meters per second. And that really is acceleration. It is how long it takes for a change in velocity to occur. If we look at another graph, let's say we have a car, which, this is a velocity time graph, gets faster to a velocity there, and then it goes along there. And we've got x and y. We've got 10, 20, 30. And let's have 1, 2, 3, 4, 5, 6, 7. This is seconds. Imagine if they said, what's the acceleration between x and y? We'll use the same formula. Okay. We have a velocity of 20 at x and 20 at y. So our y here, our final velocity is 20. Our original velocity at x is 20 over, it started off at 2 seconds and goes to 6 seconds. So that's 4 seconds. 20 minus 20 is 0, divided by 4 equals 0. And you can see that this is a tricky way of them saying what's the acceleration between then and then 0. there's no acceleration, because you can see that it's constantly stayed at 20, which means it was going at a constant velocity. There was no acceleration. And so you can see on these graphs that if there is, on a velocity time graph, if there is an up or a down movement, that means there's a change of velocity, which is going to be an acceleration if it's going quicker, or a deceleration if it's going slower. If ever you get a horizontal line on a velocity time graph, it means that it's going at a constant velocity. There is zero acceleration, and you may recall that if something is kept continuing at a constant velocity, there is no resultant force upon it. All the forces are equal. So that is acceleration delivered just by doing a few calculations. It starts with knowing the formula though. Acceleration is the final velocity minus the original velocity over the time taken.